So let's start the session. So we were discussing about the difference of the current transformer and instrument power transformer. That is the type of your that is the main type of your instrument transformer. What were the instrument transformers types? So all these points that we have discussed is all of you must remember or take the screenshot of this difference between CT and PT. So now what in accumulation of the CT and PT, we should discuss what are the advantages and disadvantages. What are the advantages and disadvantages of CT and PT? So we should discuss on those topics also. So here let us take the topic named is advantage and disadvantage of instrument transformer. So from there you can see that the advantage of the instrument transformer is given in this point. First one, these transformers use ammeter and voltmeter to measure a high value of current and voltage. That means normally we already know that these two types of measuring device which can measure the voltage and current of anything. So that's why we have used here the ammeter and voltmeter to measure the higher value of the voltage and current by regulating that high much voltage into smaller value of the current and voltage. Second point is by using these transformers, several protecting devices can be operated, like relays, otherwise pilot lights. So by using this type of transformer, we can use the to protect. We can use to protect the relay from the higher value of the current. Third point is instrument transformer based transformers are less cost. Less cost means it is economically sound. Instrument transformers, as you know, the voltmeter and the ammeter that we are using for the CT and PT is of lower value of the ratings. And if the lower value of rating, that means lower small this cross sectional size of those equipments will be smaller. So that's why we need a smaller value, a smaller amount of rupees to manufacture those type of instruments. That's why we can say that this instrument transformers costing is very much less with respect to the other higher value of the voltmeter ammeter. So this is the third point. Fourth point is damaged parts can be easily replaced. Fourth point is your damaged parts of these transformers can be easily replaced. Next point is these transformers offer electrical isolation among measuring instruments and higher voltage power circuits. Whether these transformers offer electrical isolation among measuring instruments and high voltage power circuit, so that electrical insulation requirements can be reduced in protective circuits and measuring instruments. This is the fifth point. The second last point is by using this transformer means instrument transformer. Various measuring instruments can be connected to a power system, just like your watt meter, or you can say another voltmeter or ammeter. Those are some equipment that we can connect with the power system. Okay. Next point is low power consumption will be there. Low power consumption will be there in protective and measuring circuits because of the low value of the voltage and current. So these are some advantages. Of the instrument transformer of the CT and PT. Now the next part is what is the disadvantage? All these are the advantages of CT and PT. The next question is what is the disadvantage of the CT and PT? So there is only one disadvantage and it can be used simply for AC circuit, not for the DC circuit. This is the main disadvantage of the CT and PT. It can be only operational for your AC system, not for your DC circuit. Okay. So now, so these are the some advantage and disadvantage of CT and PT. Next point is testing of the instrument transfer. How we can test some of the instrument transfer, whether it is working correctly or it has some damage. So here you can see that testing of the instrument can be done. It is written here. The instrument transfer like CTs. CTs means current transfer. Play an essential role while monitoring and protecting the electrical system, because this CT is connected to the relay, and this CT is used to protect the relay, as this CT reduces the current flow through the relay. So this can be called as the protection system for your relay that is connected in the power circuit. So this transformer mainly is used for changing the current from a diminished secondary current by using relays, meters, control device, and other instruments. So the testing of an instrument transformer is essential when metering or you can mixing of connections and protection faults occurs. Otherwise, high degree of exactness can be reduced drastically. Exactness means your accuracy. Exactness means the accuracy, high degree of accuracy is reduced if we do not test the instrument transformer properly. Simultaneously, electrical changes with a current transformer will occur. So due to above these two reasons, it is necessary to verify and adjust current transfer along with their connected devices at normal intervals. There are some electrical tests employed for this task to ensure exactly optimal service, like reliability, like radio, polarity, excitation, insulation, binding, and burden. So these are the some tests that must be done on your instrument transformer. That is your first radio test, then there is a polarity test, then there is excitation test, then there is insulation test, winding test, and burden test. Okay, so these are some tests that is used to test the instrument transformers. So these are some top points that we must remember for the instrument transfer. There are some other differences between CT and PT. So in that scenario, if you do, as we compare, if we compare the different types of CT and PT, we can see that if you find the value of definition, then you can see that for CT, it is written here, transform that current from higher value to the lower value. That is the first point. Potential transfer from higher value of the voltage to the lower value of the voltage. Okay. Now it can say this current transformer is step up transformer. Okay, because this is decreasing the value of current, but when you go through the transformation ratio, the transformation ratio, the current ratio is inversely proportional to the voltage ratio. So if it is decreasing the value of the current from higher value to the lower value, from primary to the secondary, that means it is increasing the voltage from higher value to the lower value. So it can be said as your step up transfer, whereas potential transfer, it is decreasing the value of the voltage from higher value to the lower value. So it will be named as your step down transform. This is named as your step down transform. Now the circuit symbol of your current transformer is this. This is your primary current that is going through this, and going through the straight line. But when you rotate this number of turns and the current is flowing, then it is called current in the secondary winding flowing. Like this is the primary side voltage, this is secondary side voltage, this is the incoming current, this is the outgoing current. The dot is showing the same type of current, that is either incoming or outgoing. That is the same point. That is the primary voltage and this is the secondary voltage. Now, what is the core part? For how the core is different from the different from current transformer, potential transformer. So it is given here. The core of the transformer of the current transformer is built up with lamination of silicon steel that we have discussed. In the potential transformer, the core is made up of high quality steel operating at low flux density. Low high quality of steel operating at low flux density means the hysteresis loss of this type of core is smaller. That means the width and length, that is area of the hysteresis loss is less for this potential transformer of the potential transformer with respect to the current transformer. Similarly, the next point regarding your primary winding is it carries the current which is to be measured. In potential transformer, the primary winding carries the voltage which is to be measured. Secondary winding, it is connected to the current winding of the instrument. Fine. In the secondary winding, it is connected to the instrument. Same thing. Connection. This is connected in series with the instrument, and this is connected in parallel with the instrument. Or you can say this is a series transformer. This is a parallel transformer. In primary circuit has a smaller number of turns. Good. This is a large number of turns in the primary. Similarly, in the second circuit, has a large number of turns and cannot open circuit. It works on the condition of short circuit condition. Similarly, in the secondary circuit of the potential transformer, it has a smaller number of turns and can be operated as open circuit. The range is of value 1 ampere or 5 ampere, but the range of the potential transformer is 110 volt or 120. Now, transformation ratio is for current transformer is high. The potential transformer transformation ratio is low. Burden. Burden is the does not depend upon the secondary burden, and the second potential transformer depends upon the secondary burden. Okay. Next one is the input. Input having the constant current. In the potential transformer, it is a constant voltage. Full line current, the primary winding consists of full line current. Similarly, in the potential transformer, the primary winding consists of full line voltage. Types, then there will be two types, wound and closed core. Two types, electromagnetic and capacitor voltage. Impedance, it has the low value of impedance in the current transformer. The potential transformer, the impedance will have the higher value. Now the applications for the current transfer, the application is measuring current and power, monitoring the power grid operation for operating protective relay. Then there is an application for the potential transfer is given as measurement, then power source of operating protective relay. So these are the some application of both this type of transform. Now here you can say this is your current transformer. This is the secondary winding, and this is the straight line, straight rod. That is a primary winding. This is the secondary part, and this is the ammeter connected with the machine, or you can say current transformer. Similarly, in case of potential transformer, you can see here, this is the actual circuit diagram. This is the actual circuit diagram of your potential transformer, where this is the AC voltage, this is the potential transformer, voltage transformer. This is the voltmeter connected. This is the wattmeter, which measures the power. This is the ammeter, how much current is flowing through this circuit. This is the current transformer connection. This is the load. So the actual instrument transformer connection is given. So here, this is the supply voltage, supply side. When the supply side is connected in series with the current transformer, now this supply side is connected with the parallel with the voltage transformer, and this is your voltmeter is connected here. This is the wattmeter, how much power it is consuming during the application. How much power it is consuming during the application is given by this potential transformer. Okay, so these are some differences related with your current transformer, potential transformer. So now let us take about some application or type of instrument transformer that is being normally used in the industrial purpose. Just wait for 2 minutes, then we will start. I will show you some industrial. So here you can see that there are different types of instrument transformer that is applicable in different type of application in the industry. First one is your first one is, you just say these are some instrument, these are some different types of instrument that is named here. So the you can say that this is a metering current transformer. This is a metering current transformer. Metering current transformer is mainly is included in the UPS system. Then there's a transfer switches. Then there's a motor generator sets we can use. Then there's a commercial sub metering of the system that is applicable for this instrument transformer. Then there's a three cities in one. This summation of the current transformer, or you can say winding transformer indicator for power transformer. Then there you can use the metering current transformer. Then there's a standard city used as a measuring standard for comparison purpose also. That is comparison purpose also it can be used. Next one is your control panels and drives. In control panels and drives also this instrument transformer, this current transformer can be implemented. So the next one is accurate measuring of metering watt or volt ampere reactive. Then there is a three cities in one package for three phase metering purpose can be used. And there is a commercial sub metering can be used for. So these are the some. So these are the some metering transform. Now, in this metering transform, the explanation part is given here as cities are available in many different sizes with the capabilities metering of 50 to 400 hertz currents of 5 ampere to 15,000 ampere with secondaries. As you can say, for the 5 ampere, the value of the secondary is 0.1 ampere. Then there is a 1 ampere, 5 ampere. The special secondary currents are available. So, depending upon the value of the current of the transformer, we can decrease the higher value of the current in the lower value of the current. Now here burden is given as 1.2 for 2.4, 2.5 volt ampere to 50 volt ampere. The accuracy class of this type of transformer is given as 0.2 to class 0.5. It has the range. So these are some practical applicable current transformer in the application of the industry. Similarly, in large frame of the current transformer, you can see this is the large frame of the transformer. As you can see, this is the rectangular current transformer. This is a rectangular current transformer. The secondary of the transformer is lead and wires. So these are mainly window of the current transformer is fit to around the primary bus bar or cables in the application, where physical size and placements are very important. So that's why these rectangular current transformers are mainly utilized there. Okay. Then there is a split port current transformer. The split port current transformer is, you can see here, this is the split port current transformer. The explanation part is given here. That is, this type of current transformer is available to measure AC currents from 100 ampere to 600 ampere. Split port current transformer is mainly used to measure the current having the value 100 ampere to 600 ampere. Now the frequency is at 50 hertz to 400 hertz. They are very popular in some metering application where existing systems are being upgraded and it is impractical to isolate the primary current. Okay, so these are some explanatory part of the split core current transformer. Normally, the range at which this value of the current transformer is used is AC current of 100 ampere to 600 ampere at the frequency of 50 hertz to 400 hertz. Okay, so normally the two model of this SCCT transformer is given as SP and SPS. SP and SPS of the type of split core transformer. Then there is a relay class protection current transformer. These are the type of the transformer that is mainly used to protect the relay from the higher value of the voltage. So here you can see the application of this type of transformer is given here. So the first one is your protection relays or relay panels. Second one is the earth fault protection is given provided through this mechanism. Third one is a bushing type, oil immersed current transfer in power transformer. Then there is a control panels, this control pans and switchboards. Then there is application of air or gas circuit breakers. Then there is a motor control cubicles. There you can use power control centers, the place at which this type of current transfer can be used. Then there is a bus bar protection system. There also we can use this type of current transformer. Then there is a differential protection system that we have used, that differential protection system that we already studied in the relaying of the power system, where there we can use the differential protection system. So these are some applications related to this, to the relay type of current transformer. Now there is a three-phase current transformer also there. Okay. Now, for the three-phase current transformer, there is a application. This is named as miniature current transformer. Miniature current transformer explanation is given here, that these are constructed using one of the following methods. By using one of the following, that is plastic cast casing, then there is resin case casted, then resin taped and tape insulated. So these are the some manufacturing process through which we can manufacture or build up a miniature current transformer. Now the turns ratio of this city must be in the ratio of 4,000 to 1. That means this is, if you have the primary in the 4,000 ampere, the secondary will have the 1 ampere. Similarly, or you can say the ammeter variation of the range of the value of the ammeter will look like this. Similarly, for 500 ampere to 1 ampere. So these are and the accuracy of this type of transformer is given as class 1 to class 0.1 to class 1. Now the application of this type of miniature current transformer is given here. First one is energy meters for accurate current measuring. Then second one is current control. Then third one is current signature of motors. Then fourth one is load sensing. Fifth one is ground fault sensing. Sixth one is monitoring of process parameters. Then AC level to logic conversion and bar graph. Then there is as a transducer instrument. So these are some these are the some current transfer that we have discussed for the practical purpose. As you can see, this is the medium voltage current transfer. By seeing the diagram or by seeing physically, you can verify that this one is for higher value of the current transformer, higher voltage current transformer, or medium voltage current transformer. So the generator styled current transformer looks like this, just like a horseshoe, just like a simple example of horseshoe. Medium type current transformer looks like this one. Then oil insulated current transformer, power transformer, as you have seen this type of transformer in a power system book, or you can see in switchyard, this type of transformer named as your current transformer. These are some current transformers given. Then there is a potential transformer. You can say this is the potential transformer diagram is given. The potential medium voltage potential transformer looks like this. This is the medium voltage potential transformer. Then there is a sensor of the circuit transformer. This is called Rogowaski sensors. Rogowaski sensor that I will show you some other diagram of this Rogowaski sensors in next class. But first, it looks like your armband. It looks like your armband. Okay, so these are some CTs and PTs difference and the application that you use in the your application of the transmission system. In the switchyard, normally this is type of current transformer. Okay, this is a type of current transformer. So by seeing an instrument, we can verify that which one is your CT and which one is your PT. Now there is some other instruments. There's some other instruments is given here. Let me first disconnect. So here we can see that. Wait. So in the conclusion part, we will discuss some of the conclusion part related with your instrument transformer. The rest part, that is the video that I will show you related with your potential transformer, current transformer in the next laboratory class. Okay. Till now, the conclusion part of the instrument transformer is given here. I'm going to show you the conclusion part. So what is the need of the use of instrument transformer? In the basic format or in the just simple format, we have three amenities through which we can say that what is the user transfer. First one is for the circuit isolation. Second one is reduced voltage and current to reasonable working levels. Third one is phasor combination, summing and mixing. So these are the some three important things for which we need to require instrument transfer. Okay. Then there is a type that is voltage transformer. There is a control power transformer. So these are the some instrument transformer circuit is given here. You can see from here. This is a symbol of current transformer. This is the primary current and this is the secondary current. As you can see, this dot showing the one dot is for the entering purpose and the second dot is for the leaving purpose. Current leaving that point that represents your dot. The dot convention you already have studied in your transformer, simple two winding transformer. Here, if you think about what is dot, so before V1, if it is incoming, if it is dot product is showing for the incoming current, that is current entering through this point. Then for the V2, at this node, this dot will represent you. At this node, current will leave from this point. So current will leave from just by entering from here, then again it will leaving from here. So this is the symbol of the circuit symbol, dot symbol for your current transformer, and this is the symbol for your voltage. This is the symbol for your voltage transformer. Okay. Now the conceptual picture of the current transformer is this. This is the primary number of turns. This is small lesser number of turns, and the secondary number of turns of the current transformer is higher. Okay. Now the conceptual. This is the ABB company that is very much leading company for the electrical system. So from here you can see that this ABB transformer, this is the actual, this is the V1 supply and this is the V2 supply. And the type of construction that we used in the instrument transformer, this is type of current transformer. Then this is a current example of the transformer, that is the primary side, this is the secondary part. This is the voltage transformer. This is the voltage. This looks like a voltage transformer, and the voltage example transformer circuit diagram. This looks like this. So construction. This is the window type. This is the part type, and this is the window type. This looks like a toroid. All these things looks like a toroid. Okay. Window type, because of this core part. This is a circular portion. This is the rectangular portion. This is the air core part. Okay. So these are the some type of construction of the instrument transformer. These are the some example. These are current transformer type of cities. That primary conductor for this one is your primary conductor. That is the rod flowing through the middle portion of the air core of the secondary core. This is the iron core. This is the iron core, but the middle portion is the air core, and that the winding that is provided on the iron core is given as the secondary, named as your secondary winding. Now the transformation ratio, as you already know, the primary current divided by secondary current, or you can say secondary voltage divided by primary voltage, that will give the transformation ratio. So by seeing here, you can see that this is the 5 amps. This is the 5 amp current transformer. This is the primary current flowing through the 100 ampere. This is the overhead transmission line flowing through current flowing through the overhead transmission line. When you provide a current transformer, that will convert that amount of current in very small value because of the number of turns that is provided from the current transformer. Okay. Now the transformation ratio is given as primary current upon secondary current for your current transformer, and for the primary transformer, this is the primary voltage upon secondary voltage. Now what is the nominal ratio? The nominal ratio is given by this. For the CT or current transformer, it is named as a rated primary current. That is the nameplate given on the CT and PT. That value is came from the nameplate. That is rated primary current and the rated secondary current division. The ratio for the PT is rated primary voltage upon rated secondary voltage. That will give the nominal ratio. Now the turns ratio is given by number of turns of the primary winding divided by number of turns of secondary winding for PT, and number of turns on secondary winding and number of turns on the rated primary winding, that will for CT. Now what is the ratio error for your instrument transformer? The nominal ratio minus actual ratio divided by actual ratio will give you the ratio error for your instrument transformer. The phase angle error, that will given by this formula, 180 upon pi Lm cos delta minus Le IE sin delta upon N upon S. So now what is burden? So from here you can say that burden is convenient to express load across the secondary terminal as the output in volt ampere are the rated secondary voltage burden due to load. Okay, so this is the burden of the machine, burden of the instrument. So these are the some characteristics of the CT. Then there will be characteristics of the PT will be there, that will be discussed in our next class. Okay, so till now we have just completed 40% of the components of CT and PT. We will deal some parts in the next class. I will show you some YouTube video of the CT and PT, explanatory part of CT, in our next class. So thank you very much for today's class.